Hello and welcome to this second film in the series of 4 about stage 3 mole calculations. Like films 3 and 4, this one's about percentages in calculations, and in particular this one deals with percentage yield calculations. So that is basically what we're saying here is a percentage yield tells us what percentage of what we could have made, but looking at the balanced equation, have we actually made. So just to try and make that a little bit clearer, here's an example calculation. Okay, we are told that we've got 40.8 grams of this substance, C6H6O3. Okay, and we're being asked to find the mass of water that forms. Okay, and we know that that is the number of moles times the molar mass. But what we're also told here is that we're only going to make 39% of what we ought to have made according to the stoichiometric ratio. So that tells us that 1 mole of this reacts to form 3 of those. Okay, but instead of 1 mole turning into 3, it's going to turn into 39% of 3. Okay, so we're only going to make 39% of what we could have possibly made according to our balanced equation. Right, so bearing that in mind, let's go ahead and do the calculation. We know that the mass of water is the number of moles times the molar mass. Okay, we need to know the number of moles of water for that. Okay, and that is equal to the number of moles of C6H6O3. Or at least it's related to it. Certainly not equal to it because there's 3 there and 1 there. So is the number of moles of water greater than that? Yes, it is. So we're going to put the 3 there and the 1 there. If we'd gone the other way up, then the number of moles of water would have had to been less than that. But not only is it 3 times greater than that, it's going to be 39% of that number. So times 0.39. Okay? So let's find the number of moles of C6H6O3, and that is equal to its mass over its molar mass, which equals, 40.8 over 12.01 times 6 plus 1.008 times 6 plus 48 for the oxygens, which is 40.8 divided by 126.1, and that equals 0.324 moles. And if we multiply that by 3, so the number of moles of water is 3 times that, and times 0.39, then we get the answer. What do we get? We get 0.379 moles. But we're not asked to find the number of moles of water that form, but what mass. Okay, so the mass is equal to the number of moles times big M, which equals 0.379 multiplied by 18.016 for water. I've just done that from memory because that's what happens when you do it a few times. You remember that that is what the molar mass of water is, and that equals 6.82 grams. Okay, so there's a percentage yield calculation. Hopefully that explains what a percentage yield is. We are saying that when we've got a mole ratio, the percentage yield tells us what percentage of that mole ratio will we get, essentially. Okay, so instead of turning all our reactants into products, we only get a certain percentage of products out at the end. Here's another one. For the balanced equation shown below, in the reaction of 20, so we've got 20.7 grams of calcium carbonate, and I've got 6.81 grams of calcium oxide. What is the percentage yield? So this is going at it from the other way now. We're trying to find the percentage yield, so let's find the number of moles of calcium carbonate. Okay, that equals the mass over the molar mass, so 20.7 over 100.09. Okay, and what does that equal? That equals 0.207 moles. Why am I doing this? Because I'm trying to compare this mole ratio to the actual mole ratio, which is 1 to 1. Okay, so number of moles of calcium oxide, that equals 6.81 0.81 over, what's the molar mass of calcium oxide? 56.08, and that equals 0.121 moles. Okay, so this mole ratio is telling us that we should, if we started with 0.207 moles of calcium carbonate, we should have got 0.207 moles of calcium oxide. But we didn't, we only got 0.121 moles. So what is 0.121 as a percentage of 0.207? Well, that's how we find that out, isn't it? Okay, so let's do that, and that gives us 58.7% apparently. Okay, so that's coming at it from a slightly different direction. That's seeing how much ought we be able to make, how much did we actually make, and turning that into a percentage. Okay, we can't just do it in masses, right? Notice that I haven't just gone straight ahead and taken these and used them as a ratio, because these two things have different molar masses. I have to turn them into moles first so that I can compare the quantities. All right. The next two films are about percentage composition, and it wouldn't be fair of me to finish this film without reminding you of that.